starten. Okay then. So we're going to talk a little bit about computer vision.
Start recording.
Have we can. We're not going to go in depth because computer vision, well, it's a pretty big topic. You can talk for hours about it, go deep dive into convolutional neural networks or whatever. We're not going to do that. We're just going to give a brief overview and talk about some platforms, tools, and algorithms you can use in your robotics project and how to basically combine it with ROS. That's the main focus here. So a bit of an overview. Yeah, what is computer vision? Interdisciplinary scientific field that deals with how computers can be made to gain high-level understanding from digital images or videos. Basically, getting computers to see, right? It seeks to automate tasks that the human visual system can do. So you can guess, why is it important for robotics? Well, it's pretty handy if your robot can actually see what it's doing, where it is, and what are the objects in its vicinity, so that it doesn't, drive into a human, for example. That's of course plus. So ability of computers to see, acquiring images, visual information, processing it, analyzing it, and understanding it. So computer vision. So basically what you want it to do is, well, when you have your robot, if it moves around in the world, you want it to be able to map its environment and really interpret everything that's happening around it, everything that is in its vicinity. It's kind of at the intersection of a lot of different fields, and it can also interact with a lot of different fields. So basically, optics, obviously. Neuroscience is important because a lot of the breakthroughs in computer vision also happen because we try to use some biological principles to basically make our computer vision algorithms stronger, more robust, better. Machine learning, of course, robotics here, speech and NLP. There's a brief intermezzo about basically the large language models that have really gained a lot of power and popularity over the past year, and how you can basically transition between speech and images, which is also a very interesting field. So the recent history of computer vision, you can go 500 million years into the past, but let's stick to the 2000s. So in the early 2000s, there was like first real-time face detection, basically. It was the Viola/Jones face detector, not based on deep learning, but based on hierarchy-like features, mathematical concept, basically. Not going to go in depth about this. But then later on, actually, what was the main focus was creating a data set or data sets. And actually creating large data sets. The Pascal VOC was the first, and after that came ImageNet. And actually with the creation of these data sets, the field kind of exploded, because especially ImageNet, it was like a few million labeled quality images that could be used for everyone to basically train their object detection software on. And then in 2012, you got AlexNet by the University of, I forget, where AlexNet was created. Berkeley could be. In any case, the details can be found on the internet. In any case, this was like the first neural network, or convolutional neural network that won the ImageNet classification contest. So basically that was a contest organized around the data sets on ImageNet. And this one was suddenly like way better than all the previous years. And this really set in motion the deep learning revolution within computer vision. And since 2012, since AlexNet, winners have always been convolutional neural networks. And basically, I don't know if we have that chart. Yes, we do. So the classification results have gone, well, the error rate has gone down dramatically, and especially the last like 5-7 years. This is not a picture where you have like human, how well a human does on the ImageNet. If I remember correctly, a human is between these two, like 0.05 error rate approximately. So we've gone past basically how well humans can classify images. But then another big one was YOLO/darknet. So you only look once. Maybe some of you have heard about it. It's a unified real-time object detection system. The handy thing about this is, well, first, it's fast. Two, it can classify images and also detect where it is in the image. So a lot of convolutional neural networks and the ones and like AlexNet and the ones used in the ImageNet competitions were mostly about just classifying what's in the image, but YOLO also detects where it is. So really great, and it all works in quasi real time, depending on which version of YOLO you use. So we have a YOLO example later on that I'll come back to in a sec. Other computer vision improvements, well, there's a lot. I'm not going to go over everything, but this is just from 2023. So a lot of papers are published, a lot of new algorithms are coming out. There's a few like big convolutional neural network architectures that people are improving on a lot. So you have a few of the, like a HasNet or a VGG, or so these are kind of the big players. And then there's a lot of improvements on those neural networks. Won't go into the details. You can find a lot of resources about these deep learning architectures in the Google Drive. So if you want to know more, please feel free to check out those resources. Then since 2020, we've also seen a rise in vision transformers. So transformers are a type of deep learning neural network architecture that's usually used in natural language processing, or that's where it originated at least. And the cool thing was that a lot of the time, what you see in deep learning and neural networks is that you can kind of transfer one architecture to another domain, and you actually can gain some pretty good results. So we saw that with vision transformers. And another handy thing about it is, I won't go into the details, but a transformer works with a sort of attention mechanism, and the attention mechanism is something that is trying to figure out what are the important elements of the input data. So for text data, this means certain words or terms that are important. For image data, it means certain parts of the image that it focuses on in order to do its classification. And you can use that then to explain to a user, for example, why your algorithm classified a certain image a certain way. Like you see here on the bike, what did it focus on? Well, literally the part of the image that's actually the bike. Right, and you have a few example models here. You can look into the details if you want. Then this, I'm not sure how long this video is. Can we? Let's go for it. it's not that exciting anymore. But so what it's basically touching upon here as well is well, a technique called segmentation. So we were talking about object detection, object classification, and segmentation is basically, well, that you try to identify what each pixel in an image actually represents. So it's a bit of a object detection on steroids kind of thing. So enough already. Next slide. Yes. So I don't know why we're not full screen anymore. Let me just full screen again. I'm not allowed. Okay, let's keep it like this then. So interpreting images through text. I alluded to this earlier. Basically, what we're seeing now, well, this is an example from GPT-4, but I think, I'm not sure anymore if they disabled it or if it's still, if you can still use it in GPT-4, like the API. I'm not sure anymore, but in any case, what they did was basically attach like a large language model to computer vision, and well, I make it sound simple. It was a bit more complicated than that, but basically combine these two fields to see what you can do with it. Well, we also see it in tools like image generation tools, DALL-E or Stable Diffusion, where you prompt it and then it creates an image. So it's basically the overlap between the domains of natural language and computer vision. There's a lot of potential there. So that's what we're going to see in the next few years, I think. Other things around computer vision as a broader category, you can like transform other input data also to a sort of computer vision problem. Like, for example, classifying sounds, you can create a spectrogram of the sound, like the frequency response, and you can then classify it based on this. That's one example. Another one is mouse clicks on a website and mouse movements. You can also create a sort of images of like the movement of a user on a website and then classify it based on this. You can even, this was a experiment around malware. You could basically visualize the binary code of malware and classify it in that way. So it has broad application. That's basically what we're trying to say. Then mini sidetrack to OpenCV. Important also in the field of robotics because it's usually your interface with to working with images. Basically, it's open source computer vision library, cross-platform, real-time, well documented. There's a really big community around it. C++, Java, Python, anything you want. You can get it at opencv.org. The ROS Noetic Docker, of course, is already installed. There's a few examples as well. So what are the capabilities? Well, it has a bunch of things like object identification, but the non-deep learning variant, face and gesture recognition, again, not the non-deep learning variant. Things like optical flow, like how objects move throughout a scene, visual odometry, which we'll go into more detail later on, structure from motion, like if you have a camera and it's basically going around, for example, this thing, and then you try to recreate a 3D model based on all the images you took around it. Stereo, multi-camera calibration, depth computation, all important things in robotics as well, right? Because depth important to who is arriving. That's also good. So yeah, lots of capabilities. Like here, it basically works on features, but nowadays you use more deep learning techniques for these kind of things, also for face recognition. But interesting nonetheless. So yeah, optical flow is the pattern of motion of objects and surfaces. And these are all just built into OpenCV. So there's a lot of potential there. I won't go into too much detail here. You can look through it yourself. There's a bunch of videos as well. Interesting to watch. So if you want a mini tutorial of which we have all the example code gathered in the Docker environment, this video is definitely good to watch. If you're a beginner to OpenCV, this is definitely a good video to watch, and then follow along with the examples we have in the Gauss Noetic Docker environment. You can find all of it under example code and then OpenCV. There is more information in the learning path document if you want to figure out how to run these examples and what to do with them. But basically, it's just Python 3 and then run the example, and then you'll see what happens. I'll show you one example shortly, and after that, we'll show you a more integrated YOLO example. Then repositories, libraries, frameworks. Maybe I'll give the word to Robin shortly now, if that's okay.
Yeah, we have included some libraries, some repositories that are publicly available. I have not included them all, but just the ones that we are encountering the most actually in literature. Maybe the most important one is Hugging Face, actually a platform for all kinds of data sets and models and different topics. As you can see, I just added a screenshot. On computer vision, you have models for image classification, for segmentation, for detection. And what is nice is that it's all in one kind of library that you can include. So the model code of the architecture is just something you can include and then work with into your applications. Also different applications. Yeah, it's actually quite nice. Maybe next one. Then another thing that we encountered actually just a few months ago is 51. Is actually something that you can install in Python. Also, open source data sets. It's useful for open source data sets viewing, actually, especially for images, really efficiently, how you can visualize your data sets or the variance between images, as for example, actually quite nice. Also for your computer vision model building, quite nice, and also for the evaluation. And look into that. Another one is OpenMLab. It's PyTorch based, but I think the best of the biggest advantage here is that you can deploy into multiple libraries again. You can create TensorRT models, you can create Onyx models, and even convert between them quite easily. So if that's something that you need, it's also very useful, and it's also a lot of computer vision related tasks are included, like tracking OCR, future time. So we look into that. Also something that we worked with, especially the last few years, and we are working with the NVIDIA Jetson devices, the embedded devices, TX2 or the Nano or Xavier is NVIDIA DeepStream. NVIDIA DeepStream is a framework from NVIDIA, of course, that is actually quite useful for creating pipelines if you want to have real-time applications. It includes a lot of, how can you say it, optimized building blocks, elements, especially for those embedded devices, but you can also use it for workstations, for example. But I think it's mainly recommended for embedded devices. And again, you can create and train your own models. You can convert it into certain optimized model versions if you want to have certain optimizations like N16 or N8. It's all possible. Also, TensorRT models you can include and just put it in the pipeline. Though I have to say, it is quite a steep learning curve to get used to this because the support, the documentation is not that quite fantastic, I think. But once you are getting familiar with it, you have found some examples and you can work with the examples, of course. And it's quite nice and actually performs most implementations that you can find of the NVIDIA Jetson devices. So yeah, always nice. And then something that NVIDIA has quite recently came up with is the NVIDIA Tau toolkit, a toolkit that also supports the latest vision transformers. And again, it's just a framework for training and optimization. But yeah, from what I've heard from people in work field, is again, it's a new NVIDIA toolkit, so quite a steep learning curve again. Not the most examples out there yet on NVIDIA Tau. But yeah, it has support for different frameworks. You can easily deploy onto multiple platforms. Also, you can work in the cloud on your own server or workstation, all through NVIDIA Tau toolkit. So in theory, it looks nice. In practice, I'm just mentioning it because yeah, it's something new and maybe you can look into that. And then yeah. Yeah, YOLO nowadays, Ultralytics instead of PJ Ready, like it began with, got commercially available now. Yeah, it's now from Ultralytics, and yeah, now pipelines. It's mostly supported now into pipelines, as far as I understand, and also can export the YOLO models, like we mentioned, like some mentioned before, to TensorFlow, also to I think it's Robo Vision. What is it? It's Onyx maybe. The local?
Yeah, that's Onyx.
Onyx, yeah, sorry. So yeah, deploy to multiple platforms. So yeah. Also, yeah, what kind of algorithms YOLO supports now? Yeah, it all started with classifying, but also detecting. Segmentation, you have always seen, but YOLO can do it now. I think in YOLO V7 or 5 already. Segmentation?
Since V6, I think.
V6.
I'm not sure.
Track and even post estimation is possible nowadays. Also, YOLO, especially for real-time applications, quite recommended and perform quite well nowadays on modern hardware. So, yeah. And then, yeah, media pipes, just another example that we came up with. Not all the examples that we are mentioning now we have worked with before. So just what we see, what we have on the plan to look into. A media pipe is one of them. Also easily deployable to, you can easily deploy your application to mobile, web, or desktop. And it's also a machine learning framework. Yeah. So yeah, and data sets, okay, Hugging Face, we have already mentioned actually a lot of data sets, but also a lot of models that are included into that. Kaggle, also very useful for especially data sets. Sometimes there are tutorials also as well. If you want to work on a data set, maybe sometimes it has a tutorial with a certain model to just get familiar with it. RoboFlow is something I don't know.
Yeah, RoboFlow is basically, you often use it in conjunction with YOLO, for example. It's basically a platform where you can label images really easily. So that's what it's very handy for. Yeah. That's why I included it.
Yeah, and then finally papers with code, but I have a slide on that as well. Next one. It's actually also a website a bit like Kaggle, but more into different models that are implemented along with the papers that are published. And what is quite nice is that you can see you can group different papers to the data set that they are tested on. So you can see, like you see here, okay, on a specific data set, you can see how all the models are performing on that specific data set. And you can see, okay, what is in certain conditions, maybe the most interesting one to use in my applications, and also what is the state of the art on a specific data set. So quite nice to see. Not all papers on computer vision are on papers with code. It's just a bit along the others if they publish their models and code to this platform. But yeah, sometimes you can find something really interesting.
How is YOLO currently used? Because it uses dark web to operate. And let's say you use it with RAWs. Is that something you can bind?
Yeah.
I have an example. I'll show you in a second. All right, so we have.
Maybe I don't know. You have seen the PIP install from Ultralytics. Ultralytics PIP install that includes YOLO nowadays in Python.
Yeah.
So you can just work with that directly. I think you need to have the right idea, right? Of course, maybe also CUDA installed.
Otherwise, it runs on CPU and it's slow.
Yeah, that's so, you can do little fun things, maybe for an image with real-time processing. That's good. Not being recommended.
All right. Yeah, I'll just go quickly over some examples. We have like maybe 10 minutes, and then we'll have a longer lunch break of around 45 minutes, I would say. I think that's okay, I hope. So let's go into our ROS noetic Docker. Don't know what was running here. I'll just start from the beginning. And
There are other terminals already running, so.
Can I just exit everything?
Yes, and inspect if the container is still running and just kill it and run a new one. That's a beautiful. It's in stories.
Oh, you put it in QWERTY. That's
You can
That's
switch.
something.
You can switch.
where is the? Oh no, it's not here. It's in repositories.
Yeah.
Okay. ROS noetic Docker. All right. Actually, I will switch because otherwise I'm gonna go insane. So let's open the noetic Docker again. Maybe slightly bigger, like this. Okay, so maybe really briefly, the example code of computer vision, well, OpenCV basically. You can find it here. Might center it more. That's maybe easier. Here we go. So here you see a bunch of examples, like reading in an image, using a webcam, image transformations. Maybe I'll just do a quick image transformations. And you can run them just with Python 3 and then like translate and rotate. And then you see it opens a nice Mars rover image. And if you press enter or any key, maybe I think.
Probably any key.
Probably any key, you can see that it translates the image and rotates further, rotates even further. And like basically like this. If you want to look at the code, not here, just gonna go into the ROS noetic Docker folder. Like you can use Visual Studio Code. I don't know if everybody's familiar with VS Code, but it's one of the most used development platforms, so I'm guessing yes. And basically here you have the example code. He said, yes, I trust the authors because it's us. And then you can basically check like what's happening. It's all quite well documented wherever necessary. And if you want to know more about OpenCV, go through these examples, try them out, look at the code, see what it does, basically. And then I just want to show you a YOLO example. Not here. I don't know where I clicked. In order to do this, I think you'll have to execute a Catkin make in the project's Catkin workspace folder. So if you will follow along, I can actually just look here. If you follow along with me, execute a Catkin make and then source it. Actually, you don't.
I didn't tell what sourcing was. Skip that part. So
just follow along.
Yeah, okay, just follow.
No, but go ahead. You can explain.
Okay. Yeah, if you build code in a Catkin workspace, especially if it's C++ code and using services or messages, there are a lot of or few environment variables that are set, and you should set them by hand by sourcing a specific file. So every time you build, you have to resource that file so that
environment variables are correct. Very irritating, but that's
Yeah.
ROS life.
So-
ROS1 life.
It's also in the troubleshooting guide. If you run into like these very typical issues, it's usually because you either need to do a catkin make or source your workspace basically. So you can start the YOLO example by executing start_YOLO_example.sh. Basically, what it's gonna do is open a bunch of terminals and download a model. Basically, it will start a few things. It will start a ROSBAG at half speed for now, which is just a kind of a stock YOLO model, and it recognizes some stuff like a chair, person here, and it's so it is getting this via ROS. It's analyzing it with YOLO, and then it's sending it on another topic where other ROS nodes can basically do something with the information. So if you look in, for example, Arvis, and I'll open that real quick to show you. So here, Arvis, what am I saying? RQT graph, that's what I wanted to open. Here, I don't know if you've shown
Yes.
RQT graph. Okay. So basically, you can see here that, well, it's a very simple system for now, but this is the ROSBAG. We're getting the images over the image raw topic. This is the YOLO object detector, and it's detecting, and I'll show you in the code in a sec, and it's detecting where the objects are and what labels they have, and then it's sending it on a detected objects topic to, well, on the topic, and then you can do with it whatever you want. So the YOLO example, you can find it here under projects in your Catkin workspace. It's it's basically a package with just one Python script in there. And the thing is with YOLO, it's quite easy. So basically, you install the Ultralytics Python package, and you can load a pre-trained YOLO model like this. So it's one line of code, and then the rest happens. So what is the rest? Here you start the whole thing. So what is it doing? It's subscribing. I'm guessing it didn't told you everything about publishers and subscribers and everything. So it's subscribing to the image raw topic. So, and when these images are received, it goes into the image callback function, which is here. So the data contains the image received on the topic. And what we're doing then is converting it to an OpenCV image so that you can do something with, well, using OpenCV. That's what we're doing here. And then we're using the YOLO model that, well, we've initialized here to predict on the CV image, and the prediction results. Basically, you get like the bounding boxes that you could see in the video. I'll show you again in a sec. Oh yeah, like this bounding box. You get the coordinates of this bounding box. You get the coordinates. You get the label, which is chair, and you get, yeah, you cannot see it here anymore, but you can see the confidence with which it knows it's a chair. So like a certain percentage. And then this information is sent on a on the detected object message on the detected objects topic. So, and that you can use in other parts of your application. So it can be as simple as this to set it up, basically, which is really neat, I think. Okay, so that's basically what I wanted to show. And then it's exactly exactly 12:15. Perfect timing. So I'm thinking we'll go into lunch now. I'll stop the recording here.